Good afternoon, welcome, and thank you for joining today's Storage Forum, Energy Markets for the Future. Before we begin, please ensure you have opened the chat panel by using the associated icon located at the bottom of your screen. If you require technical assistance, please send a chat to the event producer. You can submit questions by using the All Panelists selection from the drop-down menu in the chat panel, enter your question in the message box provided, and send. For optimal video viewing during the panel's discussion today, please select the grid view by using the layout button located in the upper right corner of the content screen. With that, I'll turn the call over to Jimmy. Please go ahead.
Thank you so much, Grace. Good afternoon, folks. My name is Jimmy Bashara with the ISO Stakeholder Affairs Group. It's my pleasure to welcome you to the Storage Forum, Energy Markets for the Future. We are pleased to be hosting today. And of course, thank you to everyone for joining us virtually. We very much appreciate your participation and engagement in advance. As a reminder, we are requesting written questions only, as you may know, as Grace mentioned, throughout the chat feature. The questions will be fielded throughout the discussion, and we will have, if we have time at the end, for final questions as well. More generally, we'll get to those. We do ask that you please stay on topic and, of course, be mindful given the volume of values that we have today, over 700, I believe, which is fantastic. And after the introduction, the ISO will provide an overview of storage, and then we'll go right into the three main topics, which, as you may know, are the ISO RTO market design and interaction with deep storage levels, modeling considerations for storage, and model interaction with different storage technology types. And as a final reminder, this is being recorded, and the recording will be posted onto the Public Forum's webpage, along with the other meeting material. And would you please request that any recordings and transcriptions not be reprinted without the ISO's permission. And without further ado, I am very pleased to introduce our CEO, Elliot Mainzer, to provide today's welcome and introduction. So, Elliot.
Thank you, Jimmy. Hello, everyone. Thank you so much for joining us for today's Storage Forum. I'm really appreciative of the level of interest in today's topic. Jimmy said we've got almost 700 people who've registered to join us virtually today. And this forum, of course, today comes just 2 weeks after our extended day-ahead market forum on October 13th, which was also, I think, very well attended. And your participation today further ratifies our belief that we will do a much better job defining problems and defining solutions if we harness the collective knowledge and experience of our broad energy community. So thank you again for being part of today's conversation. This, of course, is a very exciting time for energy storage in California, as we've been integrating lithium-ion battery storage onto the grid at really an unprecedented scale. And as we push into new frontiers of energy storage development, we are actively learning and working hard to ensure that we have the appropriate products and protocols to take full advantage of this crucial source of clean capacity. And I have to say, even though this is very much a work in progress, the battery storage resources that have come online this year have been performing very well. Of course, there are always some bumps on the road with new technology, but from the ISO's vantage point, this new resource has been doing its job very well. I'm excited about the conversation we're going to have today with our distinguished speakers, who will provide valuable insights into how market design can enable and leverage evolving technologies. We've brought some of the world's foremost experts together to discuss the market design principles for storage and how our market may evolve in the next 5 to 10 years as we see significantly more storage coming onto the system. In addition to our own Gabe Murtaugh, our panel representing practitioners, researchers, and academia will have a lot of interesting things to say about market design, the interaction with storage resources, and modeling considerations. We welcome them and really appreciate their willingness to share their considerable knowledge with us today. This past summer, the ISO relied on storage resources to get us through some very challenging grid conditions. The increased battery capacity and its ability to respond when needed was extremely valuable in maintaining grid reliability. We were able to build on the lessons learned from the summer of 2020, which helped us adapt and develop models for storage resources to function effectively in our electricity markets and meet our net load peaks without disruptions. Coincidentally, as many of you who have joined us today may know, the ISO has also led the Energy Storage and Distributed Energy Resources Initiative over the past 7 years. It proposes to enhance the ability for storage and demand response resources to participate in our markets by making state of charge parameters biddable in the market. The initiative also applies market power mitigation to energy storage resources, among other enhancements. Just this week, FERC accepted our tariff revisions for this initiative to move forward to implementation. Of course, these changes would not have been possible without the support of this community of stakeholders and regulators. So thank you again for your support. Storage is now poised for tremendous additional growth in California in just the next few years. We have about 2,000 megawatts of installed storage capacity today, an 8-fold increase from last summer. We're on target to have 3,000 megawatts of installed capacity by the end of the year. The California Public Utilities Commission has issued procurement targets of 3,300 megawatts of new capacity by 2023 and 11,500 megawatts by 2026, and 1,000 megawatts of that is required to be long duration storage. In fact, the ISO anticipates that a significant fraction of this new procurement will be storage. California, of course, has a lot of hard work ahead to meet its ambitious greenhouse gas reduction goals, and storage will play a pivotal role in helping us get there. It will help us bridge the gap when renewables are not generating or generating at low levels, and it will help maintain a reliable grid by adding resiliency during those periods, as well as when the sun is going down and evening load is increasing. Storage can also be valuable during extreme weather events that will continue to threaten reliability and can be used to keep critical infrastructure online. It can also provide non-wire solutions to meet local transmission constraints. We also have to acknowledge some of the challenges, including the fact that many of the storage resources coming on the grid today have contractual or tax implications that limit their ability to charge from the grid. These limitations have potential reliability consequences, and we need to work together as an energy community to address them. Today's forum is intended to help us think about these challenges. It will help us consider the best market tools and methods needed to provide incentives to storage operators and developers that will align with the reliability needs of our grid. We have already seen the tremendous value of storage on the system this year, and I'm excited to help enable energy storage to continue to shape and strengthen the grid and the broader market in the West. I would now like to introduce my colleague, Gabe Murtaugh, who is the storage sector manager for us here at the ISO. Gabe is going to kick us off with some background information before we start our conversation today with our expert panel. And thank you all again for participating in today's important conversation. Over to you, Gabe.
Thank you very much, Elliot. I appreciate it. Hopefully my volume is coming through. I'm on a different device than I usually use, which is dangerous.
Sounds good.
Such a big meeting. So hello, everybody, and thank you so much for joining us today. It's a real pleasure to be speaking with you. And as Elliot said, this is a very large group, and I'm just deeply and profoundly thankful for the interest and the level of engagement that we've already heard on some of these topics. We have an extremely good panel of experts who are going to speak to us today about organized markets, and I'm very excited to hear what they have to say and some of their feedback and input on the questions that we put forward here. I also appreciate that Elliot is doing such a nice job of teeing this discussion up. A lot of what he said is really the crux of what are driving some of the questions that we're thinking about in terms of market design for today. And just on that note, I have received a number of questions over the last few weeks about why the ISO is asking these questions now and what we're expecting to get out of the discussion that we're having today. So I would like to walk through a little bit of the reasoning of why we're here and what I'm hoping to get out of this. I would like to say that we are thinking about this a lot of times in terms of, and a lot of these questions in terms of US-based markets and how changes that we're anticipating making could impact those markets and resources that perform in those markets. But I think this also has global applicability because this certainly expands beyond the kinds of questions that are just relevant here in the U.S., as there are many countries who are tackling the same problems today that we're also thinking about. So with that in mind, state regulators today across the U.S. are imposing wide and sweeping reforms on requirements on how electricity will be generated in the future. And specifically, they're specifying that we will be using less and less greenhouse gas emissions to produce electricity and serve load in the future. And those goals are going in many states across the country, not just here in California. Our specific greenhouse gas goal is that we are entirely greenhouse gas free in electricity generation by 2045. And thinking about that question and how the grid of the future is going to look in 2045 once we've reached or are getting close to achieving that goal is really what I'm thinking about when I'm talking about some of the questions that we'd like to address here in this forum today. Specifically, we're thinking about a future where our generation is predominantly coming from, wind and solar resources, and then storage resources are being used to bridge the gap when the sun isn't shining or the wind isn't blowing. This really isn't an easy task to set goals for in terms of setting up organized markets to ensure that we have reliable grid operations. It's hard to put rules in place, and it's hard to get procurement targets right to get to these 2045 goals or other climate goals that states may have. But it's even harder to effectuate and to maintain grid reliability in the meantime. So I think that drives us to the real reasons for why we're here today. And some of the questions that have been puzzling me and my colleagues are, well, what happens when we do retire the gas resources, which have been the predominant marginal resource on our grid here in California for the last, dozens of years? And instead of gas resources, we're now left with wind and solar resources and storage resources. What do our markets look like here in California? What do other markets look like across the country? How do we gain efficiencies from partnering with other markets across the country? What kind of products, and are those products different than what we have today, are going to be used to make sure we procure the right mix of resources? And how do we ensure that as we're making those procurements, we're also compensating the underlying resources appropriately and incentivizing growth and the correct mix of resources on our grid? So I think this is a good sort of array of questions to start thinking about. And, I do think that we have a very good panel here today to at least kickstart that discussion, as we do have many thought leaders in the areas of market design. And we also have a good cross-section of not only knowing about organized electricity markets, but also thinking about emerging technologies like storage and how these resources could fit into organized markets today. So my goal for today is to hear from these experts about some of these questions and to consider some of the directions that we might start to head in to address some of these questions. I'd also like to think about how we could, not necessarily completely revamp our markets to meet these goals, but how we might start adapting these markets that we have today to start a glide path towards where we think we're going to be in the future. Frankly, this really is the beginning of a conversation. We really are in just the first stages, as Elliot has just mentioned, of developing and integrating storage resources onto our grid. So like many other conversations we've had recently about storage, I think we're likely to come out of this conversation possibly with more questions than answers. But I do think it's important to at least start thinking about these questions so that we can have a thoughtful and deliberate approach as we do start to modify some of the tools that we use to maintain grid reliability going forward. My hope is that some of the ideas and conversations and potentially new questions that are brought up in this discussion will be kernels for future development and future conversations on electricity market design. And it's also my goal that these conversations don't just happen here in the state of California, but they happen in the organized markets across the country and indeed across the world. I fully expect that the electricity industry is a collaborative group, and I do expect that in the future, as we go forward, there will be a significant amount of learning and sharing from one organization to another as we do try new solutions and we see how these solutions work and we iterate and build better markets for the future. So just to level set, we are not here today to discuss any active or open policy for the California ISO or any other ISO or RTO. This is purely a standalone event, although I would be remiss to not point out that the California ISO does currently have open a policy for developing new tools for storage resources. It's called Energy Storage Enhancements, and you can track that on the California ISO website, or you can reach out to one of my colleagues and we can get you plugged into that initiative if you're interested in participating. I do think that participation from anybody who's on this call today and anyone who's interested in storage and organized markets, it would be relevant and useful, and we certainly appreciate comments and input, as do all ISOs who are working on stakeholder initiatives to design new markets today. So Elliot has already mentioned some really interesting statistics about storage resources. Jimmy, if you could advance the next slide, please. I have here a graph that I've put together that illustrates the information that Elliot just presented. And it does show that right now we have on our grid today about 2,000 megawatts of storage installed. And last summer, it was something much closer to 500 megawatts. So we're really growing very, very rapidly. And by the end of the year, we're expecting to have about 3,000 megawatts of installed storage capacity, which corresponds to the orange bars in this graph. The blue bars correspond to new hybrid resources that we're anticipating coming on the system, which could be likely either renewables or storage capacity, but they're not broken down into storage or renewables per se on this graph. But with that huge increase in storage relative to the size of our system, this really does mean that storage resources are now in the future more and more going to be marginal on our system. So we're going to need to be thinking about them critically and how they're interacting with other resources across the grid. So Jimmy, we can advance the next slide, please. I've put together this very high level slide on what markets do look like for the California ISO and other ISOs across the country. And this is just to give an idea about what tools we have in place today. And I think it's a good springboard for the conversation of where we might be going with market design in the future. So most ISOs do have continuous models, and this is largely a byproduct of FERC Order 841, where for a storage resource, you have a continuous range of charging and discharging for a single resource ID, which can represent energy storage resources. And this is different than the model that has been around for many, many years for pumped storage resources, which are also largely considered storage. But pumped hydro models typically are discrete, where you are operating either in a charging mode or a discharging mode. But for many of the new lithium-ion batteries that we're seeing on our system here in California, they are able to ramp very, very quickly, and they can go from providing energy to the grid to charging from the grid back to providing energy to the grid in any 5-minute, in any 3 sets of 5-minute intervals. Also, most models allow for participation in the energy, ancillary services, and capacity markets. So there is a lot of ability for storage resources to participate in the products that are available and online today. Not all markets manage stated charge for storage resources, though, so there are some differences in how stated charge is treated. And in fact, even if you're asking about stated charge management and what that means, that has very different meanings across different markets in the country. All models also allow storage resources to set prices and are not subject to transmission charges when storage is charging to provide a service to the ISO. They're providing some other service. Those are different circumstances. And I think this gets into a lot of the conversations that you hear around storage about either being load and generation or negative generation and positive generation. And I think that those are interesting questions and still need to be considered as we go forward. Most markets do consider 4 sustained hours of capacity for capacity accreditation in their resource adequacy processes. That's not ubiquitous. In PJM, you get full credit if you can show 8 continuous hours of dispatch, and you get a little bit of a haircut if you can show 6. In New York, if you can show 6 hours of continuous dispatch, you can be counted for capacity. And in New England, it's just 2 hours. In most other organized markets, the sort of default or the other prevailing value is 4 hours. I will just throw a shout out here. I got, this is mostly summary data from an EPRI study that was shared with me and documentation. So any inaccuracies here on this slide are largely my own and not EPRI's, but I do thank them for providing this information, and they're a great resource for storage information in general. So now on slide 6, if we could advance one slide, please. This outlines the questions that we'd like the panel to discuss today. And this is just a brief introduction. But the first question is, do ISOs and RTO markets include products to ensure reliable operations with deep penetrations of renewable and storage? I think this gets back to some of the questions and the wonderings that I have had previously. Is storage paid appropriately for services provided on the system? How might this be different than compensation that they need? Are additional market enhancements necessary to foster storage participation? How might that look? And I think I would preface this with saying, most of the storage development here is from those requirements from the California Public Utilities Commission, which Elliot referenced. And if we want this growth to happen organically or economically, how might we do that? Are market power issues inherent in new or existing market designs? I think, most organized markets are concerned about market power. How do things change when you start talking about storage resources? This is a really interesting question. We could have a whole forum just to discuss this. The second question, are models today missing critical aspects to operate or procure storage resources? Are small changes needed, or are we talking about fundamental redesigns of the market, and how does that look? I think that is also a fairly weighty topic, and we can spend a long time discussing that. And then the third question is, do current market constructs favor one technology? For example, we're seeing a lot of lithium ion built in the California system today, but we know that there are a lot of other technologies out there. Are different constructs necessary for medium or long duration storage? So there's a lot of questions, and clearly we're not going to be able to come up with all of the answers to all of these questions today, but I think we can at least start exploring and kind of paint a big picture of where it is we are and where it is we'd like to go. So with that, I'd like to introduce our moderator of the panel discussion, who is Dr. Benjamin F. Hobbs. Dr. Hobbs is the Theodore M. and K.W. Shad Chair of Environmental Management at the Johns Hopkins University and has been a member of the faculty of JHU Whiting School of Engineering since 1995. He holds a PhD in Environmental Systems Engineering from Cornell University, and his research addresses economic analysis of electric, power, and environmental systems. Previously, he was at Brookhaven and Oak Ridge National Laboratories and on the faculty of Case Western Reserve University and an overseas fellow at Churchill College at Cambridge University. From 2010 to 2018, he was director of the JHU Environment, Energy, Sustainability, and Health Institute. He currently co-directs the US EPA Yale JHU Solutions for Energy, Air, Climate, and Health, or SEARCH Center, and is a member of the leadership team of the JHU Robert O'Connor Sustainable Energy Institute. He was named a Presidential Young Investigator Award by President Reagan in 1986. Dr. Hobbs was appointed to the Market Surveillance Committee of the California Independent System Operator in 2001 and now serves as its chair. He is a fellow of IEEE and Informs. Dr. Hobbs obviously has a lot of prestigious accolades, but I personally have worked with Ben for about 7 years, ever since I started at the ISO, and known him to be extremely engaged and dedicated to finding and implementing elegant and efficient market solutions where they are needed and where we are exploring new solutions to market issues. He is incredibly up to date on knowledge of current market technologies and has done some very in-depth work in the storage space. He has some very deep knowledge of how storage works, and if you're just thinking about storage on the surface, it's astounding, how complex some of the modeling is for storage, and Ben knows a lot about that. He also is a teacher through and through, and there really is no question, right down to the most basic or fundamental principle, that he's not willing to discuss at whatever length is necessary with someone who's eager to learn. So I really have been fortunate to work with Ben, who is a really great colleague, and it's my great pleasure to pass the virtual baton to Dr. Ben Hobbs at this time. Ben, are you there?
Hi, can you hear me okay?
Coming in.
Okay, so thank you, Gabe, for that. And thank you, Elliot, for the introduction to this panel. I'm incredibly excited to have these 4 very experienced researchers and consultants to industry on this panel today, because they're going to teach me a lot about storage, as well as all of you. Looking forward to hearing what you all have to say about how we can make market products, prices, and processes fit for purpose as the generation mix rapidly shifts, and in particular as battery storage magnifies the importance of intertemporal interactions. I wonder whether you're going to suggest mere tweaks or fundamental redesigns. Also, I'm interested in hearing what you have to say about technology. Are the models of battery operations today fit for purpose and in the market optimizations? And 20 years ago, you would have had like lead acid battery models, and now, of course, it's lithium ion. What do we need for the future? Or do we need to really change the models, or can we define general models that will work with all sorts of storage? So let me introduce the 4 panelists. First, starting with Nikita. Dr. Singhal she's a technical leader in the Grid Operations and Planning Group at EPRI, and she focuses on emerging technology integration into operations and wholesale electricity market design and operations. She leads an ISO RTO energy storage market modeling technical working group. So the slide that Gabe showed earlier is largely due to her insights and understanding of what's going on. And she provides technical support for bulk power system operation planning simulations, including production costing, dynamic operating reserve determinations, integration of storage and hybrid resources, and finally advanced software tool development. So she's got a bachelor's in electrical and electronics engineering from the People's Education Society Institute of Technology in India. And she has MS and PhD degrees from Arizona State, also in electrical engineering. And she, in her research, she focuses on power system economics and operations research. Luke Lavin, our second panelist, just joined the National Renewable Energy Laboratory as a researcher, level 3 in the Grid Systems Group. I just graduated from Carnegie Mellon with a PhD, but he's actually very experienced. He previously worked in the Electricity Markets and Policy Group at Lawrence Berkeley and with E3 in San Francisco. Primarily, he's interested in applying computational methods, optimization, economics to electricity markets and resource adequacy. So besides his PhD from Carnegie Mellon, which I had the distinct pleasure of serving on his examination committee for, he's also got a bachelor's from Amherst College in physics and anthropology. So some of you know Ed Kahn, who once said an economist is somebody who's has physics and English as a background, which was his background, so you can tell mathematical fairy tales. And I don't know if, Luke, you would describe your background the same way.
Sounds about right. Thanks, Ben. Yeah.
Yeah. Ross Baldick, he is a professor emeritus in the Department of Electrical and Computer Engineering at the University of Texas in Austin, where he became one of the most respected and widely recognized researchers in the area of power systems over the last 30 years. His undergraduate degree is from the University of Sydney, Australia. I think you would guess very quickly where he's from once he opens his mouth. And his graduate degrees are from the University of California, Berkeley. Currently, he's researching optimization, economic theory, and statistical analysis applied electric power systems, especially in the context of increased renewables and transmission. Very recently, he's been working with the Mid-Continent ISO on storage management, and he has many insights to offer in that area. He's a fellow of the IEEE and received the 2015 IEEE Power and Energy Society Outstanding Power Engineering Educator Award. And that award is not given lightly. You're going to learn a lot from him. Finally, our last panelist is Professor Ramteen Siashansi. Dr. Siashansi is a professor in the Department of Integrated Systems Engineering and Electrical and Computer Engineering at Ohio State University. His research focuses on integrating advanced energy technologies, including renewables, storage, and electric transportation into electric power systems. He does a lot of work both on the technical side and in policy, especially as they pertain to advanced energy technologies. He previously worked at the National Renewable Energy Laboratory, where Luke is right now. He is also an IEEE fellow, and very importantly, he recently chaired the Energy Storage Technology Subcommittee of the U.S. Department of Energy Electricity Advisory Committee. In fact, he served 3 two-year terms on that DOE committee. This shows that he's a person who cannot say no, which is why he's here today, too. So, Nikita, Ramteen, Ross, and Luke, thank you very much. And I'd like to proceed to the first question, if we could, Grace, or Jimmy. And the way this will proceed is that we're going to go first in alphabetical order by first names in response to each of the 3 topic areas that Gabe outlined. Folks may have a slide or two, or they may simply just stand on their soapbox and speak. So we'll get a response from each person in alphabetical order. Then I'm going to give the panelists a chance to respond to each other. And then we'll take questions from the audience, which you can send in your chat box. So let's see, if we can go to the next slide, please. Okay, so the question is the ISO, not just the California market, but organized markets in general, are they fit for purpose? The products we have, how prices are formed, the general processes, given the challenges that the rapid growth in battery storage, together, of course, with variable renewables. At any rate, I would like to, going in alphabetic order, I think that makes Luke my first victim. Is that correct?
That sounds right to me. And
okay.
Thanks, Ben, and thanks again for the introduction, and everybody who's on the call for listening into the discussion. So in response to this first question about whether or not ISO market models are fit for purpose, I think that the answer that I would have is with the additions under Order 841 that allow for continuous operation of storage, as well as parameters like state of charge that sort of represent the technical characteristics of storage, that probably things are okay for now. But I suppose I have a couple of concerns about both pre-existing rules and how they will interact with new technologies, as well as some concerns we'll get into later about market power mitigation for resources that can look to the grid like a load, can be in hybridized configurations where the grid doesn't necessarily see all of the operating parameters, the system operator doesn't. And so I think those are kind of the two areas where I'm hoping to delve a little deeper on whether rules that were applied for thermal generators are fit for purpose, as well as some concerns around market power under congestion and with a resource that can act as a load.
Okay. Thank you, Luke. Let's go next to Nikita for any initial comments that you might have to say about the question about the fitness of our markets and any of the particular topics about how storage is being paid. Do we need some more market enhancements, and is market power any issues?
Thanks, Ben. Yeah, I largely concur with what Luke mentioned. With Order 841, I think we are very well positioned to enable these storage technologies to participate in the different markets. There was one key aspect that I would like to, actually 2 points that I would like to focus on with respect to this question is one to do with state of charge management. Almost all the ISOs across the board have a mechanism in place today to manage state of charge. But it may look different depending on the region that the asset is participating in. An offer curve in one region may not have the same implication in another region, and this is primarily because of the design of the market structure to begin with. When I say the design of the market structure, I mean not all ISOs optimize across multiple time intervals. And with storage, given that energy is a limitation, this may have an impact on how state of charge is managed. Also, the designs that were put in place, we haven't really tested them out with how they would work with an increased penetration of storage resources. Will there be computational tractability concerns with the ISO managing state of charge with an increased penetration of storage resources? So we'll only get to validate that and test how these designs are working once we have more of these assets participating in the market. The second point that I would like to also bring to attention is that it's also for us as an industry to come together to understand how important opportunity cost bidding will become in the future. Now, one would anticipate that with an increased level of renewables, the location and marginal prices or the wholesale electricity prices would reduce in general. Now, additionally, the expectation would also be that in order to avoid shortage conditions, there would be potentially high LMDs, a few periods with high LMDs. But however, it's also important to note that renewables are still likely going to be the infra-marginal units in a majority of these time periods. And it's going to be storage that is going to be filling the gap in order to reliably satisfy the demand, as Gabe also mentioned. So if these resources are going to be filling in the gaps, they're likely going to be the marginal resources who are also going to be setting the electricity prices. So it's very important to get those prices right. And FERC Order 841 also included one key aspect that storage must be eligible to set wholesale prices both as a buyer and as a seller when marginal. So, we need to really get into a very detailed discussion in the next few years as to how do you go about determining these opportunity costs, mitigation concerns around these opportunity costs, as Luke mentioned as well. But these are the 2 points that I wanted to bring to attention today. Thanks.
Okay. Thanks, Nikita. Ram team.
So thank you again for the very nice introduction, Ben. So at the risk of not repeating what's been said already, just a few things that I want to add and highlight. I agree with the other two panelists. I think in the short run, the market reforms that have been made in response to 841 are fairly good. But I think as we're thinking longer term, the way that I view this is I like to think about what are at a fundamental level, what are the products that we need to procure through the market? And the products that we need may be changing as the resource mix is changing. So a good example of this is historically, we haven't really need to think about procuring inertia because that's just something that kind of naturally comes from the resource mix. And we may be moving to a future in which inertia becomes a scarce resource. Now, the power electronics folks tell us that power electronics and control systems can be designed to give us virtual inertia, but do we need to define products around that to remunerate people for installing, developing those systems, and then using them in the proper way? The second key question that comes to my mind is, are the important, at least kind of first order technical characteristics of energy storage captured in the market model? So for instance, Gabe mentioned that a lot of these market models assume kind of continuous charging and discharging capability, and that's probably reasonable for some set of storage technologies, but for some that may not be. And of course, in the generation market, we've decided in North American markets that modeling non-convexities such as unit commitment is important from the perspective of dispatching generation. So we have to ask the question of whether that's important from the perspective of dispatching storage resources as well. This issue of a third question to my mind is this, Nikita mentioned this question of seams between market periods. I think one of the issues is that the markets as they're set up right now, I think they're better suited to short duration energy storage, where you're looking at intraday or maybe interday shifting of energy. But at some point, we're going to need to start thinking about longer duration seasonal energy storage. And then Luke mentioned this question of market power mitigation. Well, market power mitigation becomes a lot trickier when you're thinking about opportunity cost, looking 6 months down the line or something like that. Final thing I wanted to note here, with respect to the design of these capacity markets, so subject to the fact that load patterns and resource mixes are different in different parts of different ISO RTO markets, I find it a little hard to believe that the sustained discharge duration can range between 2 to 8 hours to get full accreditation. So my suspicion is these are kind of ad hoc numbers, and of course they're ad hoc numbers that vary by a factor of 4. And that obviously has major implications for storage investors.
Team, I am shocked to hear that we'd be using any ad hoc numbers. Simply shocked. Ross.
So thank you, Ben, and everybody at CAISO for inviting me to participate in this event. I would like to step back maybe just a moment to argue for what I think is part of the underlying philosophy of U.S. organized markets and therefore the implications for storage. And I think one of the principal things in the philosophy of U.S. markets is an offer structure, that is to say the information that the generator provides to the ISO, including all of the extra bits such as minimum up and down time and so forth, that matches the technology. And if we look at why we designed electricity markets in the 1990s, let's say, we had predominantly thermal generation. Of course, there was always pump storage hydro in the background, but predominantly thermal. And if we want to match the technical characteristics of those generation assets, we need things like three-part offers to include startup, no load, incremental energy. So that's what we've done for thermal generation, and Ramtin alluded to that, and I should say I want to build on what Ramtin was saying. There are a bunch of advantages of this philosophy. First of all, if you have competitive offers, the ISO can just optimize them on the basis that they represent the underlying costs. How do you make sure they're competitive? Well, market power analysis is relatively straightforward. For most of our technologies, we know within maybe 5, 10, 15% what the actual costs are because we can guess what the fuel costs are. So you can more or less do market power analysis. It's relatively straightforward, although obviously all of the market power analysis for transmission constraints in the US is not straightforward, not based on physics, and doesn't make sense, but that's a different workshop. Maybe an important thing to draw out is because we represent individual generators, there's no bias towards ownership of a portfolio of generators. And that may sound like an abstruse comment, but in Europe, for example, where their offer structure does not match the technology, you have a big bias towards a large firm that owns a portfolio compared to individual companies. In other words, you make it difficult for new entrants, small new entrants, to enter and participate in the market profitably. So there's a whole lot of good things about the U.S. organized markets, and I think it stems not from a desire to have three-part offers. It stems from a desire to match the offer to the technology. And so the question is, what does that mean for storage? Well, what it doesn't mean for storage is bids, energy bids and offers, okay? To be clear, it doesn't make sense at all to have energy bids and offers from a storage device, except in one case. So if Order 841 is leading to that, I don't think that's the right direction. What we need is explicit representation of state of charge, the range of state of charge, a time horizon. As Nikhil suggested, we do need to optimize this over a time horizon. We need to represent the round-trip efficiency. Maybe we need battery degradation. I'm not sure what level of details are necessary. That's a continued discussion with thermal generation. But I do think there is one place where explicit bids and offers are very important. That is for the end of horizon state of charge. So I think it makes sense to think of round trip efficiency and end of horizon state of charge, either a desired level or more usefully a bid or offer to deviate from that desired level. And then finally, what are the implications for price formation? We should have opportunity costs predominantly resulting in price formation, opportunity costs from resources that actually have well-defined marginal costs flowing through, together with the bid and offer for the end of horizon. So that's what I would say is, from a philosophical perspective, what's needed in models of storage technology. And I appreciate that deviates perhaps from Order 841 implications and probably deviates from what many of the folks on the panel and certainly the audience might have to say.
Thank you, Ross. I think that will probably stimulate some sort of response, but definitely if we look at the offers that batteries have been making in the California market over the last few months, some great data that Guillermo and his team have been putting together, we see if they are opportunity cost-based offers, that wildly vary among seemingly nearly identical facilities, which at least says to me that, and as we wrote in the Market Surveillance Committee's opinion in ESDR 4, that just what you propose, which is, at least in the day-ahead market, no opportunity cost-based offers, rather just the technical parameters, maybe some degradation, no O&M cost, and then something to deal with the end effects at the end of the horizon. So I'm sympathetic to that, and I'm wondering what the other panelists think about Ross's proposal to dispense with bids to charge and offers to discharge. And anybody could just unmute.
Ben, it sounds like to me that you all are proposing that there not be an opportunity cost component in the day-ahead market. And I suppose the concern that I would have is this seems like it would work okay for 4-hour batteries. But if you have no way of representing your opportunity cost on a longer duration storage resource, it seems like you may have an issue.
Great point. I think I agree with, I think that's what Ramteen has said also is consistent with that. And of course, we deal with that now with hydropower and pumped storage in a very different way, and not necessarily very well.
But Luke, that's the point of allowing bids and offers for the end of horizon. So that's precisely why one needs an end of horizon bid or offer for deviating the state of charge from, let's say, some nominal value. And that precisely incorporates the knowledge of future, but it dispenses with what Ben has identified as strange effects due to perhaps different opinions about costs and marginal costs during and within the horizon, within the optimization horizon.
I think I take Ross's point, but I think then my question is, how do you know that the end of day or the end of the time period offer is actually competitive? Which is to say, without some estimate of opportunity cost beyond the end time period, the end of the time horizon, how do you know that whatever is being entered for the desired SOC and the offer to deviate is in fact a competitive offer?
There are two sides of this basically. This issue, all of this discussion started with FERC Order 841. One of the key requirements within the order was to allow for asset owners to self-manage their state of charge. And that was the reason why ISO started to introduce the capability for these assets to now offer in their charge and discharge offers, which, but not explicitly consider state of charge within the model. On the other end, what Ross is talking about is pretty much similar to how an ISO would manage the state of charge, because they have information about the entire system. So if you were to include end of horizon state of charge constraint, automatically the software is going to know when is it optimal to charge versus discharge. Now, the question comes about how do you determine what should be the penalty cost to deviate from the target state of charge constraints, right? Like, so think about it in the real-time market where you have a shorter horizon. You could use information from a previous cycle. When I say cycle, you could see, I need to say, let's look at results from the previous run. That was the day-ahead market. So you have state of charge constraints modeled in the day-ahead market. The shadow price of these state of charge constraints are indicative of what the value is. What is the value? What is the opportunity cost of holding back state of charge at the end of the horizon? So that shadow price can be used to then model and enforce the target or the desired state of charge at the end of the horizon in the real-time market. So this is one way that you could do it. But then this kind of removes the flexibility from the developers participating in the market, because now they cannot explicitly submit offers. Well, they still could if they have degradation costs, but that's where two sides of the argument are when it comes to state of charge management.
Ramteen, would you like to jump in here?
Yeah, I mean, I was just going to say, I think fundamentally it just comes down to whether you're using the ISO's assessment of of what the value of holding energy from one market clearing period into the next is versus using that of a private asset owner. And of course, relying on the private asset owner, I think, it makes market power concerns a bigger concern for the reasons that you and Luke have mentioned.
Okay, before we go to panelists, questions to the panelists from the audience, I'd like to see if anybody else would like to say anything at this point. From the panel? Okay, we do have, with 700 people in the audience, each asking 3 questions, it's a lot to sort through. But first, it would be, I think there are a couple of people who have asked some basic definitional things. So what is meant by end of horizon? And I will quickly answer that as that's the last interval, the end of the last interval in the market model. And if the model believes that the world ends at that point without valuing the water in storage in a hydro reservoir or the energy storage in battery, you will simply drain everything. So that's what's meant by that. Okay, so somebody asked, I think this will bring some more of this discussion in focus, how do we avoid the apples to oranges comparison of 7-day management of pump storage, such as Helms, versus Moss Landing's batteries at 4 hours, especially concerning their end of horizon offers or anything else? Does anybody think that we're doing a bad job of managing pump storage and, of course, the extensive hydro resources we have in California and the Northwest and the rest of the West now? And if we are doing a decent job of that, are there any implications for the discussion of designing these markets for batteries? Do we really have a problem?
Ben, in response to that, my view is that pump storage hydro is a whole different technology, right? So because these technologies can have discontinuous operating ranges, they require a different modeling approach. So there's more complexity associated with a pump storage hydro resource. You have to introduce something called binaries within the optimization problem. So today, what some of the ISOs do is they restrict an offer to either charge or discharge by the pump storage hydro in certain intervals. So they cannot offer into both charge and discharge. So this basically puts the onus on the pump storage hydro owner to decide when would it be good to charge or discharge. And they fairly have an idea based on historical operations. Now, when it comes to very long duration pump storage resources, one potential option could be to introduce multiple target state of charge constraints. So at different points in the optimization horizon, you could say that, hey, you have to get to a certain level of optimization horizon at different, let's say you're looking at 3 days, maybe at the end of the first day and the second day and the third day you reach a certain point. So these are decisions that really depend on how you want to manage the water quantities in the reservoir and the duration of the reservoir as well. Is there an opportunity to make money in the next day? Then maybe have the state of charge level reach a certain point at the end of the horizon in day 1. This is just another approach, basically.
Does anybody else want to address the question of how well we manage longer duration storage today, and whether there are any lessons from that about our ability or issues with managing shorter duration storage?
Has the market monitor had any opinions on that?
We probably don't have a representative from there, but definitely over the last handful of years, the ISO has been very concerned about coming up with what are called default energy bids, which is basically opportunity cost bids for much longer duration storage, not in the context of pump storage, but rather in the context of, for example, Northwest Hydro. That's been a very difficult problem because you may have no idea what snowpack you're going to get or what the situation will be at the end of the summer. And instead, some rough rules of thumbs with pretty generous, I would say, headroom over those based on future energy market prices in the regional energy markets has been basically the approach to dealing with them. So I can imagine with multi-day storage, you could likewise look at energy prices on regional exchanges for some guidance of what might be an excessive offer. Because as Nikita pointed out, if folks can set their own price for the end of horizon charge, I could withhold capacity by just setting a very high opportunity cost. And I think the regional markets forwards might give you at least half of them. Anybody else have a suggestion?
But Ben, precisely because of that, you would at least be the ISO would at least be able to optimize the charge or discharge within the horizon, even if it had to get the state of charge back to, let's say, what the starting point was. So at least you'd eliminate the problem that you've described, where you've got battery resources with wildly different prices within the horizon, which, to take up on your point, must imply inefficient dispatch within the horizon, whatever the perceived opportunity cost is at the end of the horizon. So you could at least deal with the within horizon stuff. Now, to my point about market power, if people are making a specific bid and offer at the end of the horizon, as you've alluded, you can compare it to regional indices and other issues. You can also compare it to what is obviously the right way to operate a pump storage hydro that has roughly a day or so of storage. You fill it up in the weekend and you discharge it gradually. You let its end of horizon, drop down, exactly as you allude, right? So we know how to do that. It's not that isn't rocket science, so to speak, but harnessing that capability and flexibility within the operating day to help with compensating for within day uncertainty of renewables would seem to me to be of huge value. And by integrating it better into the ISO optimization, surely you would be delivering considerably more value than having to cope with these resources that have offered widely varying prices, which, as you allude, inherently means they're being inefficiently dispatched, at least amongst themselves.
Okay, thank you, Ross. I'd like to turn to another couple of questions, which there are at least a couple of attendees who think that we may be leaving some value on the table. So here's one question and then the related one. Can the panelists talk about potential benefits of real-time intra-hour co-optimizing of energy and ancillary services, assuming computational power is not a constraint? Are we leaving operating capabilities on the table by procuring ancillary services in the day-ahead time frame before we know what's going on in real time, before those uncertainties are largely resolved? Now, we're in a world where, with a multi-gigawatt battery fleet, they're always committed. They have $0 startup costs and no minimum load. We have a lot of flexibility. And so the related question, I think, we emphasize the same point. What's the benefit of real-time inter-hour co-optimization? That is exactly the same question. Sorry. Anyway, so do we need to acquire ancillary services in a different time frame to do the optimization differently in order to take advantage of this much greater flexibility we have?
Ben, I think there are two questions there. One question is, should we be, let's say we know what the AS requirements are. We procure them forward in a day ahead, a financially binding day ahead market, and then we perhaps reallocate them in real time between resources in order to take advantage of opportunities. My understanding is outside of ERCOT, most ISOs are already doing that sort of real-time co-optimization. But I think the question actually was about, should we have AS requirements endogenous to the market? In other words, instead of a week in advance deciding that we need this much resource, that much resource, should we have a forecasted day ahead level of what the AS requirements are, but just like demand could change in real time compared to day ahead, we might have AS requirements changing in real time compared to day ahead. I think that would be potentially a worthwhile advantage. There's a huge political downside of it. It would identify that large generators are the reasons we need spinning reserve. It would identify that increasingly renewables are the reason we will need incremental regulation. And it would become impossible then to simply allocate AS cost to load when you had an explicit endogenous model of cost causation from generators to AS requirements. So that second thing might be desirable, but it's probably a non-starter from a political economy perspective, to be straightforward about that. To be more candid than perhaps I should be on a public event.
This is why we invited you, Ross, because we knew you would be candid. And of course, everybody knows about the alligators of cost allocation. If you raise the question of cost allocation, that's a great way to freeze up any single process and get a lot of yelling going. Luke, Nikita, Ramteen, would you like to say anything about short-term within the hour optimization versus day-ahead optimization in general?
I mean, I'll just add as a general just observation, a lot of energy storage technologies are quite flexible, and so any modeling capability that can essentially harness or make use of that flexibility is going to reveal that value to, that societal value essentially. And if you have a very, rigid day ahead, hour ahead process, then you potentially are leaving potential value streams on the table because you're not able necessarily to capture the value of that flexibility.
Yeah, I would just add that multiple intervals in the real time is, so there are two ways to think about this. Some ISOs do optimize this over one single interval in the real-time economic dispatch. So with that, especially with storage, you're really just looking at feasibility of the state of charge in the next interval. With multiple intervals, you have, although you're not looking at longer horizons in real time, but still you have some ability to ensure that you're looking ahead at least the next hour. So there is some advantages and disadvantages to both. One helps with reaching desired state of charge levels in a longer multi-interval real-time scale approach versus the single. So this really depends on the existing market structure and how much effort it would take to make any changes if they're needed. That's how I would look at this. Yeah.
I did get a follow-up from the person who asked the question about day ahead versus intraday. I think this is quite right. The questioner said, I'd argue that true real-time co-optimization doesn't exist even in the California ISO, given the T-minus 75-minute bidding time frame. So storage has to bid more than an hour ahead of time, and that's not going to be responsive perhaps to real-time changes in opportunity costs. You can't rebid every 5 minutes. And so as a result, there's a danger of, for example, draining batteries in the middle of the afternoon when you should be saving them for the evening, which is one of the motivations for the Storage Enhancements Initiative of the ISO. So would there be benefits to allowing more frequent rebidding, or do we need some other changes in the markets? Any thoughts on that?
Well, I think that again speaks to the need for an end of horizon bid offer. But if you're going to require the battery to make it in 75 minutes in advance, it also speaks to the folly of having energy bids and offers for each of those 5 minutes that can't possibly follow actual real-time behavior on a moment-by-moment basis, but an end-of-horizon offer or bid could much more possibly reflect anticipation about what's going to happen in 2 or 3 hours' time. So to me, that simply reinforces the need for the combination of specifying the characteristics plus an end-of-horizon bid or offer.
I agree with Ross. On the other hand, if you were to allow bids more close to real time, you have to also mitigate these bids. And in order to mitigate it, sometimes you need to solve unit commitment problems, and that takes longer to solve. So that's the reason why some of the ISOs restrict the closing window for offers to be submitted to T-75. At the other hand, some ISOs are actually putting in the effort to allow for these bids to be updated more close to real time. CAISO, in fact, does have existing discussion on their dynamic offer limit tool. ERCOT is also considering offers to be submitted in real time, intra-hour offers, very close to real time. But there hasn't been a discussion yet on whether and how these bids are going to be mitigated if they are going to be updated close to real time. So then there are concerns around that as well, which we need to look into what's the computation complexity with solving these mitigation problems. That's how I look at this question.
Okay, yeah, thanks, Nikita, for pointing out the importance of market power mitigation runs in many of the ISOs, and that this bogs down the process. I thought Ross would smile at that, because I thought, Ross, you would say, well, this just supports your argument that once you get rid of bids and offers altogether and just have the end of our horizon.
Yes, agreed. And I think
maybe I misunderstand.
Absolutely. And I make an even stronger point. Since a 5-minute energy bid for a battery does not match its technology, you're adding parameters that add flexibility, that make market power exercise easier. Generally speaking, the more parameter flexibility, the more market power a market participant has. If you don't match its physical characteristics, you need a lot of parameters to use a generic function to mimic its physical characteristics. That is an invitation to market power. If you instead try to match its physical characteristics, there'll be a relatively smaller number of parameters that don't need to be updated very often or require less typical updates. I'm not talking about the end of horizon energy price here. I'm talking about round trip efficiency and so forth. And when you have less parameters, the scope for market power exercise is lowered. This is a generic result in market power, and it speaks to why certain markets require in the day ahead incremental energy offers to be the same in each of the 24 hours for a thermal generator, because the costs don't change for a thermal generator. So it's a manifestation of a more general principle, which is when you add unnecessarily to the parameterization, you will invite exercise of market power and complicate the mitigation of market power.
So I think that we've learned in market design over the last 20 years that you need complexity when physical reality is complex, transmission congestion, for example. But don't create artificial complexity. But Luke, your dissertation was on market power. Would you agree with Ross's statement about asking for more bidding parameters opens up more opportunity for market power, or is that really not a concern?
I think I've actually now wrapped my mind around sort of what Ross is saying here. And I think I mostly agree, because a lot of what I see in the research that I had done is that when you allow those this for a battery, so an incremental energy or incremental load offers to vary in time in a co-optimized DA market, that's actually really what opens up a lot of the opportunity as you sort of vary your offer over time, that the sort of optimization engine is looking at the difference between those offers in time, and that's leading to some sort of strange outcomes that can lead to market power, essentially because of all these extra parameters that are in the market. So if I understand Ross correctly, what he's saying is, no, we really should just focus on end period SOC, and sort of working back from there, the ESR owner can optimize to that parameter, and it's easier to check whether or not there's market power, as sort of you've said, based on forward energy prices or some estimate thereof, either by the private owner or by the market operator beyond the end of the time horizon.
Agreed. Great summary. Luke, thank you for clarifying my lack of clarity.
I was just trying to make sure I understood. I appreciate it.
So I'd like to ask a question building off of this, which is the fundamental problem that our real-time markets have too short a time horizon? What we really need are intraday markets whose time horizons extend past the evening peak. So instead of going one interval or 1 hour, 2 hours, and so winding up with this end of horizon problem, that we solve it over much longer time horizons? Or is that just not going to be possible anytime in the near future given present computational capabilities? Or there may be some other reasons why we don't essentially want to run more markets?
I mean, I'll say I don't think necessarily you need longer duration intraday markets. That's one way to address the state of energy issue, but it's not the only way.
Anybody else have a thought on it? Do we just stay with the very short-term real-time markets and the day-ahead market and let traders figure out the intraday stuff?
Well, maybe I should add, so I mean, it is important that the market does take into account. So if it's looking myopically at just a 5 or 10 or 15-minute market interval, then of course that's going to run into problems because it's giving zero consideration to future conditions. But if you have a, as Ross has said, if you have some sort of cost or opportunity cost on state of energy, then that's one way to take into account the seam between the current market clearing period and what's going to happen later in the day or later in the hour.
Nikita or Luke or Ross, would you see creating intraday markets as just complicating things further and not being helpful, or as being a fundamental solution to the problem?
I mean, some ISOs are considering it. It is helpful because you have better forecasts when compared to day ahead, I guess. So you can pre-position the system better and then maybe use the latest information from an intraday market as well. It's just the amount of effort required to get there. But meanwhile, I think the current structure is still, there are ways to make it work. And one being exactly what Ross mentioned about the end of horizon constraint in the real-time market, which potentially optimizes over multiple intervals. And where the information comes for how much you could relax that constraint, that opportunity cost is obtained from whatever market ran before that market, be it the intraday market or be it the day-ahead market if there is no intraday market. So there are ways to use both, and both have their benefits.
I think in the U.S. market context, adding intraday would be a pretty big change, as Ben has alluded, but perhaps a smaller an alternative. I haven't thought through the details, although I know Ben and I have discussed this parenthetically, would be to make the look-ahead dispatch and commitment financially binding. So the first interval would be the physical dispatch, and that would be physically and financially binding. And then the subsequent intervals in the look-ahead would be financially binding. And then you would inherently bring into the story looking ahead, and it would, instead of being 4 times a day, it would be every 5 minutes you would have this look ahead. Now, the settlement implications would be significant, so I'm not necessarily advocating it, but from a technical bringing it into the optimization engine perspective, it might be easier just to reinterpret the LAC decisions as financially binding. That would be presumably a smaller technical change to the ISO market, but it would have for the ISO real-time processes. But obviously, it would have settlement implications, and it might be too hard from a settlement perspective. So I would put that as an alternative. And to Ben's question, I think both of them have value. As to whether their value outweighs the cost, I mean, I think that needs a lot more discussion and thought.
Thank you, Ross. The idea of settling multiple intervals in real time, I think that's something that New York considered and decided not to do. But we do know that storage owners in California do not like having their batteries scheduled in the binding interval seemingly out of merit, inconsistent with their bids and offers, without knowing what the advisory interval prices are that are driving that. And of course, the high advisory interval prices may not be realized later. So that could be a way of dealing with that. So one last question before we go to the next general topic, which is about the modeling of storage. So we can start talking about things like degradation and stuff like that. Somebody asked about distributed resources with FERC order 2222 allowing DERs to aggregate and participate in the wholesale market. Many systems that pair storage devices with rooftop solar, such as my snotty-nosed kid in Southern California who's 30 kW on his house. Do you think that additional measures are needed to be taken to allow distributed resources on the distribution system to participate similarly and compete with utility scale generation in the bulk power markets? We have my snotty-nosed kid did that because he's paying 30 cents a kilowatt hour to Southern California Edison, bless you, while bulk power prices are, of course, an order of magnitude smaller. Any comments on how we can efficiently involve behind the meter batteries, et cetera, in these markets?
Well, Ben, my first step would be to reduce the humongous wedge between wholesale and retail marginal pricing. And that, I put it to you, would automatically fix a lot of what the inappropriate incentives might be. So that would be my first suggestion. Move a lot of whatever subsidies you're incorporating in a volumetric adder into retail prices into fixed costs or taxes. And if you really hate the rich, just tax the rich more, right? And then reduce the wedge between wholesale and retail prices, and therefore mitigate a lot of what I think is simply a product of outrageously large wedge between wholesale and retail prices, as you alluded.
So your answer is pricing reform. Nikita, Luke, Ramtin?
I think also an effective coordination between the transmission and distribution, especially when you have to start looking into distribution impacts when aggregations of DERs are participating on the bulk side. How can you reflect those distribution network constraints that may potentially arise? A lot more switching happening on the distribution side. So we have research in EPRI where we're looking at how to come up with effective coordination mechanisms to coordinate between these two systems to ensure that we're able to utilize these DER aggregations more effectively. And there are also questions around, for instance, do you allow for aggregations across a single substation or like multiple transmission nodes, because then they begin to start having an impact on the bulk system as well. Pricing mechanisms is a really good one because today distribution doesn't pay, I mean, apart from time use rates, dynamic pricing, the concept of spot pricing of electricity in the transmission is not extended down to the distribution side. So many ideas are being discussed across the industry on this topic, and I think there's a lot of work to be done here, and I think a lot of opportunity to enhance competition on the bulk markets as well.
I would add that state of energy management is going to be a little bit more dicey because obviously you can't have the RTO ISO managing every single distribution level asset. So there needs to be some coordination between whether it's an aggregator, a utility, a DSO, whoever is managing the individual assets. And then that may also mean that the parameters that describe the capabilities of an aggregation of resources may vary on a day-to-day or hour-to-hour or week-to-week basis if, individual households are doing things with their DERs. So that also kind of opens the door to, thinking through how dynamic some of those parameters need to be to maintain that coordination between the individual resources and what the ISO is doing.
I think I'd mostly be echoing what other folks have said, but it seems to me like the issue here is it's hard to represent the aggregate capability of the resource. That your Sun 30 kW array seems large, but it's not in the context of the bulk power system. And if you're aggregating multiple electric vehicles, you can imagine that if some are out driving, that changes the aggregate capability of the resource. If you decide to charge some of them earlier, that means that you now no longer have upward flexibility later in time. And in order to sort of define that resource in a way that works within the ISO context requires some kind of approximation of the physical capability of the resource that, as Ramtin says, is going to vary over time. And so that seems to me like sort of a potential area of quicksand here with implementation of 2222.
Okay, thanks everybody. I think it's time for us to move on to the second broad topic. And operator, I don't know if you, or Jimmy, I don't know if it's possible to flash up that slide, but the question there is, do the models, the representation of storage today and the way it's optimized, do those models miss critical aspects of the technology? And as a result, do we misoperate or misprocure storage resources? And if we are missing important aspects of the technology, do we need just some tweaks to the present model, or is a fundamental rethink needed? And I'm going to go in reverse alphabetic order, which means we start with Ross on the other side of the world.
Let me try that with unmuted. Thanks, Ben, is what I said. So I think, again, in our focus historically on thermal generation has been on power capacity. Again, it matches thermal generation characteristics, which typically have a power capacity, but aside from specific instances, basically unlimited energy. But when we have emergence of batteries whose costs, meaning their capital costs, primarily determined by their energy capacity, this suggests we might need to change the way we think about things. And if we have both high renewables and high amounts of storage, I think we're going to find that the installed power capacity, when we think about resource adequacy, when we think about organizing things for tomorrow, that are, we're going to find that power capacity is no longer particularly limiting, namely nameplate capacity isn't limiting, but what's going to matter is the available energy, whether that's in the next hour, in the next day, in the next week, the next month. And so I haven't thought through the implications of this, but I think, again, from that philosophical bent, our technology world is changing to one from which we had occasional times when power capacity is tight, meaning nameplate power capacity. Of course, that doesn't always represent what's available as per February 2021 in ERCOT, but we'll be moving towards a world where we have essentially infinite nameplate capacity. But the question is, does a renewable resource have energy falling on it? Does a battery have energy stored in it? So perhaps we need to think about energy as our measure rather than power capacity at a particular moment. Now, I really want to emphasize, I haven't thought through the implications of this, but it seems to me that issue is going to become problematic if we continue to emphasize resource adequacy in terms of power-based metrics, let's say.
Okay. So we could look to markets such as Brazil, which have mainly an energy paradigm, and they operate their markets very differently, successfully or unsuccessfully. Ram team.
Yeah, so I agree with all of what Ross said. Just a couple of things to add. I think it's important that for lack of a better term, just generically, the bid offer parameter structure, should be built around the technical capabilities of energy storage. Don't force a storage to look like a generator in your market model. And so, for instance, as we've been talking about, historically the market design was around supply offers from generators, and the supply offers are driven by fuel cost and, some other cost components. To a large extent, that's not how energy storage works technically. So, it's really energy limits, round trip efficiency, or maybe charging, discharging efficiency. There may be degradation elements that come into play on the charging or the discharging side. So, the parameter space that characterizes storage is probably going to look different than it does for generation, and so you want to make sure that your market model kind of reflects that.
Okay, I think we might have a technical problem with Nikita's line. Nikita, can you?
Sorry, Ben, can you hear me okay now?
Yes.
Seem to have finished. Okay, perfect. Thanks.
Okay, Nikita, you're next. If you'd like to say anything about the technical aspects of how batteries are modeled and dispatched in the market.
Ben, I got dropped off about 2-3 minutes ago, so I missed the question and the discussion in the last few minutes. So maybe Luke could go before, and I just try to get it.
I'm happy to go ahead.
Yeah.
Yeah, go ahead, Luke, and Nikita will come back. The basic question is how adequate are the ISO's models of the technical side of lithium-ion batteries? Are improvements needed there? And are there any improvements needed in how they're optimized?
Sure. So I think there's a couple things I can say here, sort of based off of Ramteen and Ross's comments. So Ross sort of, I think, stepped partially into the resource adequacy debate, which is one where, as Gabe was saying at the start of the call, most ISOs, or sort of whoever comes up with the resource adequacy construct, not just limited to the ISOs, it's still a question of the number of hours of duration of the resource, and maybe this is an acceptable approximation at low levels of adoption of energy storage. But I think that, if you look at the effective load carrying capability at much higher penetrations where energy adequacy becomes more of a binding constraint, that you will start to see that set number of hour duration is no longer really something that efficiently represents the physical characteristics of storage's contribution. So that's the first thing. And then the second thing is I've been puzzling over Ross's earlier sort of admonishment to focus on this end of period SOC. And I guess the question that I have physically about that is, for a 4-hour or especially a 1-hour battery, you may have multiple cycles within the day. So sort of how do you set the parameters there on the cycling with regard to the end of period SOC, which, does that represent one cycle SOC, 2, 3? Sort of how is that physical characteristic of storage that it might cycle multiple times incorporated into the market?
Thanks, Luke. I would think that the ending state of charge question would not be any different in that regard, and the ISO software, if it's tracking state of charge and losses and capacity, would still operate it optimally in the intervening periods, but I may be wrong. Nikita.
Thanks. So there are many aspects. There's only so much you can throw into a model. There's always a trade-off between accuracy, modeling accuracy versus the complexities, right? So it's very hard to capture every single physical feature or operating characteristic and every single technology model within the software on the ISO side. So you have to prioritize what is important, and the existing models, I think, are doing a good job. There's always room for improvement, though, and some of the parameters that come to mind, for instance, with long duration storage, you may want to think about transition times as well. There's this discussion around an enhanced combined cycle logic, for instance, right? Because you have different configurations and transition times, and in order to model that, the software gets all the more complicated. But once we do have a model in place for such complicated resources, we may as well use those models for a similar technology, like long duration storage that may need some transition time from charging to discharging. Then there's also aspects around degradation. Traditional resources do also undergo wear and tear. So how is it different? There are questions around, should we be modeling every aspect of degradation, or allow for it to be captured in opportunity cost, or some kind of an offer that the asset owner would submit? There is also existing mechanism in place. For instance, we've had discussions with other industry experts wherein today we have constraints for maximum energy utilization given fuel limitations. So if you are self-managing the state of charge, maybe allow for a limitation on how much energy is used, just a maximum energy constraint, rather than getting into complications of state of charge. But also it may not be as efficient because you may not capture round-trip efficiency losses through time. So a lot of parameters can be included in the model. This can be made, but we need to go through a prioritized effort and what makes sense to include versus not.
Thank you, Nikita. And I think, let's see, have I gotten everybody? I think, yes, I've gotten everybody. All right. Would any of the panelists like to respond to anything that the other panelists have said? And by the way, we're getting a little background noise, so if you wouldn't mind muting if you're not talking.
I wasn't completely clear on what Luke said about if you're doing multiple cycles within a market clearing period, because it seems to me within a single market clearing period, unless I'm missing something, I think the market model kind of should be able to see how it's trading off between using energy and storage versus using other resources. But maybe there was something that I missed there.
No, I don't think so. I think I've convinced myself that as long as you can incorporate a degradation cost, and as long as the sort of cost of degradation are linear, which is to say, you say it's $5 a megawatt hour for variable O&M associated with charging and discharging the battery, that it does sort of make sense that you would endogenously optimize multiple cycles within a time period if it were cost effective from the perspective of the model to do so.
Right. I suppose one wrinkle that maybe could be added here is, depending on what someone wants to use an energy storage resource for, and I could imagine the case of, let's say, like a distributed or community level battery, let's say. There could be situations in which the resource owner wants some minimum state of energy level because, it wants to have energy available as a backup resource or something like that. So it's not so much concerned about the ending state of energy, but it may be concerned about state of energy at some intervening period for some, some potential application that maybe wouldn't be captured in the ISO's model, like, again, backup energy for customer, or distribution level customer could be an example of something like that.
Okay. Ross and Nikita, you want to add anything before we go to questions?
I don't think so, Ben.
Okay.
Nothing to add.
Okay. There's already a question about one of the technical aspects of modeling batteries. So this one is an obvious technical limitation. The current model is that the model doesn't consider the fact that lithium-ion batteries lose charging capability. It goes basically to 0 megawatts as it approaches 100% state of charge. You can't just go full speed into the wall. And discharging power capability likewise approaches 0 megawatts as you discharge the battery. And this rate of power loss is not considered when making dispatch decisions. You just have a fixed capacity parameter, at least in the present model. Is this a big issue, or a minor tweak that we can solve? And or does it render the model non-convex, and it's going to be more difficult to solve? Just like pump storage models with discrete states and 0-1 binaries are more difficult to solve than the continuous battery model.
Could I clarify what the question is? Is the question that if I am, let's say, within 1 megawatt hour of full charge, then in the next hour I can't charge any faster than 1 megawatt on average during that hour because there's only that much space in my state of charge? Or is it a more subtle dynamic issue associated with the interaction between how fast you're allowed to charge and discharge the battery when you're high or low discharge positions? In other words, is it the obvious issue or is it a more subtle dynamic issue?
It's the subtle dynamic issue. So
Okay.
let's say you had 5 minutes of energy left,
Mm-hmm.
at your nominal, let's say, 3 megawatts capacity, you cannot discharge at 3 megawatts for 5 minutes because actually the power capability goes down linearly as you approach the wall. So it's this more subtle issue. Any comments on that? I think mathematically it becomes interesting.
It's similar to like dynamic ramp rates, maybe for traditional generators. At different dispatch levels, your ramp rates could change. And today, I don't believe any market structures really model dynamic ramp rates. Maybe CAISO does have the ability to model dynamic ramp rates, but it's another layer of complexity to be added to the model. It's again a trade-off, so yeah. So it's basically dynamic discharge rate, I believe, for storage then.
It sounds like it would add a linear cut to the capacity at the top and bottom end of the state of charge. So Nikita's point is taken that it will complicate the dispatch. If I'm understanding it correctly, it will clearly complicate the dispatch software, but it complicates it in the sense of adding additional cuts which would not wreck convexity. Am I understanding that correctly? But so that sounds like an issue where a standard computational trade-off. Can we get the computational capabilities up to be able to handle it, as opposed to a qualitative change where it involves needing to represent binaries, right? Which in general would be a much more unpleasant trade-off to deal with. That would be my take on that. And if this
I believe that you're right.
If this is a standard technical characteristic of batteries, then my argument would be we should include it and represent it in a way that enables the ISO to optimize around it.
So mathematically, you basically have an upper bound to, let's say, the charging. There's the upper bound, the nominal capacity of the battery, and then there's a second upper bound constraint that's a linear function of the state of charge, and so that does not wreck convexity, but it does clutter things up with some more constraints. Okay, so that's not so tough. Let's go to a much tougher one. I lobbed you a softball. So degradation. So many of you are familiar with the ISO New England simulation studies done by Eugene Lidnoff, may he rest in peace, Daniel Kirshen, and actually it was Bolin-Schu's PhD thesis, which used a linear approximation, something called the rainfall model of degradation costs, which accounts for depth of discharge and the sequence of discharges, which is a much more accurate representation, at least for lithium-ion batteries, of degradation costs, how you shorten the life depending on how you discharge. And they found that you operate batteries in the ISO New England system very differently. You do not get near as much energy in and out of them. You're using them much more for regulation and reserves, which in fact, of course, is what we empirically observed in the California ISO markets until very recently, where batteries are basically used for ancillary services and regulation. They were not bid in to arbitrage energy markets, which was a mystery to many people. And the hypothesis is that degradation costs and these complicated
Operator, I think we've lost Ben.
So Ben, this is Gabe. Can you hear me now?
Yes, I'm sorry, my computer shut down. It was getting too hot. I guess the debate was getting good. At any rate,
too heated.
At any rate, so comments on modeling of degradation, which sounds like it might make a big difference in how batteries are used, especially moving from a constant dollar per megawatt hour charge for degradation to something more complicated. Would it make a difference? Is it worthwhile doing? Is the issue overblown?
Well, if I can chime in, I mean, we allow for, stepped or piecewise linear cost functions for generations. So I could see doing something similar for degradation. It's just, maybe the shape ends up being non-convex because you get these very high degradation costs when you're at very high and low state of energy.
it does interest me that I don't hear from resource owners, battery owners, big complaints about how the ISO represents degradation and degradation costs, that people somehow don't want, there's nobody saying, please put in our master file our rainfall model parameters. But so that seems a contradiction between what I saw in Eugene's study of ISO New England. Is it a second order issue and let's not worry about it?
Maybe it's a changing issue because of battery technology developments. Man, I have a lot of respect for everything that Eugene did, but maybe there's also an issue whether or not battery technologies are evolving and changing their degradation. I can imagine that lithium-ion for car, where you're accelerating and decelerating, therefore jamming in power and pulling it out very rapidly, would be a big driver of trying to get those degradation costs down. So I wonder whether this is something that we need to look at as to whether or not the battery technology is changing.
Who knows battery technology? Nikita.
I'm not an expert in degradation costs, but there's also the option to maybe play with the minimum and maximum state of charge bound itself, so that you're not going through a deep discharge. So maybe the way to go about it in the near term might be to limit the state of charge dispatch range, basically, so that you don't go through a 0 to a max state of charge, rather just limit it to avoid degradation. But one question that I have is that even with regulation, there are many more cycles, right? Because you're constantly being called to provide regulation. So does that not have an impact on batteries? And then why is the case that they're able to provide they prefer to participate in ancillary service markets and not energy? One obvious answer there is that, even in ancillary services with regulation, it's the most valued ancillary service price, so ancillary service, so that may be a reason why they're participating in regulation alone. But just the frequent movement in regulation itself should cause concerns with degradation. So why is that not a concern? More questions than answers.
Yeah. So I think it has to deal with the depth of discharges in regulation. It tends to be higher frequency and lower amplitude, but folks who know more about this than I might have something to say about this. I do have a message from a battery expert who says that I'm not sure what these acronyms stand for. LFP, I guess that's lithium-ion battery, has near linear degradation, but NMC and NCA is more nonlinear. And so I'd love to see a definition of those acronyms in the chat box or from somebody. But it does sound like that, as Ross hypothesized, that the technology may be changing. Somebody else just mentioned that regulation for most battery technologies is far less degradation than full cycles. 100 cycles of 1% shift regulation is far less wear than a single full discharge cycle. Let's see. Luke, I see you leaning forward a little bit. You have anything you want to add to this about degradation?
My earlier comment was based on sort of an assumption that the degradation cost might be able to be represented either by a constant or a linear parameter. And it seems like if you can approximate it that way, you can get part of the way there. But if you can't, it does seem a little difficult. And then the other thing I wanted to make sure I said is I feel like we're flying a little blind here in the absence of quantitative estimates. I have nothing but the utmost respect for Eugene's work and ISO New England and all that kind of stuff. But is this something where, as a function of storage penetration, we expect it to become worse? As a function of variable renewable penetration, we expect it to become worse? in terms of how we'd want to cycle the batteries. And so therefore there's some point at which we sort of want to do a benefit cost trade-off of adding complexity to the market model. Since I feel like Nikita in particular has expressed a lot of concerns based on experience about how quickly models will solve in the presence of additional binaries, additional constraints, et cetera, et cetera.
Okay, thanks, Luke. There's a comment from an attendee who says that they disagree that technologies are changing to significantly impact degradation. Technology is not changing to significantly improve that. It will remain a concern. So it might be hypothesized that the first order problem is managing state of charge and ending state of charge. Bidding degradation is important, but not as important as that. And so perhaps as we manage state of charge better in the future, perhaps it'll become more important. Any last comments or questions about the representation of battery technology before we move to the third topic? If not, we'll go to the third topic, which is what's on the horizon. As I mentioned before, if we were here 20 years ago, we'd be talking about lead acid batteries, and even just 5 or 10 years ago, lithium ions batteries were not as good as they are now. I had to replace the battery in my Honda Hybrid, unfortunately, for example. What's coming down the pike? Do we see any big challenges in terms of going to stuff that has, let's say, compressed air energy storage with, say, 24 hours worth of energy storage rather than 4, or other technologies that are maybe longer term, have more longer term? Will that present any different challenges to the markets? Do we need to be starting to think about that now? Do the market processes and models that we have here, are they giving an unfair advantage to a technology that may be obsolete pretty soon and present barriers to newer technologies? Any thought on that? And I didn't say what order I would ask people, so let's go back to the original order, which was Luke, Nikita, Ramteen, and Ross in alphabetic order. So Luke, do you want to say anything about new technologies and medium duration storage?
Sure. I think the only thing I want to say is something that was brought up a little bit earlier, but I feel like we haven't totally revisited, which is my understanding is that CAISO has this resource adequacy construct that's a little bit focused on an X hour duration, where X is 4, and that there's been a lot of adoption so far. I mean, there will be longer duration technologies under the 1 gigawatt mandate, but that a lot of the adoption so far has clustered around 4-hour duration. And I think that the concern there is maybe that sits outside CAISO's jurisdiction, but do we get clustering around a certain type of technology in early entry because of heuristic rules, and sort of when do we need to evolve those rules to make sure we get a resource mix that's not inefficient in some way in the long run?
Thanks, Luke. Nikita?
Yeah, so I think when it comes to some of these long duration storage technologies like compressed air, for instance, they're cheap. Lithium ion begins to become a little cost ineffective at longer duration levels. So although these compressed energy storages are cheaper, they not be as efficient in chasing prices for energy arbitrage opportunities. So it may be more important to start to research means to compensate and incentivize such technologies for longer term needs, like the discussion we've been having on resource adequacy. They may be cheaper to manage for longer term needs. Another aspect with medium and long duration storage, again, is to do with maybe potentially a need for different participation models that do consider transition times between charging and discharging. And then we already had the discussion on maybe potentially including some sort of a means to manage the state of charge through different points in such long optimization horizons so that you're prepared for different days. Those are the few thoughts I had, immediate thoughts. But then again, there's the one thing that we should always be mindful of, that the more details you put in, it's bound to improve the representation of the technology and theoretically improve economic efficiency and reliability, but it does come at a cost of impacting the tractability of these models. Yeah.
Okay, thanks, Nikita. Ramtin.
I'll just add a quick comment, kind of building off of what Luke said. So the 4-hour requirement that California's resource adequacy construct has in place, essentially says that there's no marginal reliability resilience benefit to having energy storage with longer discharging duration. And I think we kind of know intuitively that's just not correct. So my guess would be the good people of the state of Texas would have liked having a 20-hour duration storage device back in February. But as I understand it, the market doesn't.
60 hour, please.
Well, beggars can't be choosers, Ross. So we give you a few additional hours. But as far as I can tell, there's no mechanism in place to really ascribe a value to that beyond if a individual consumer is willing to say, I'm willing to pay for that level of resilience. Grouping of customers, I don't see that there's really a mechanism in place, and whether there needs to be some changes thought about along those lines.
Okay, thank you, Ramtin. Ross?
Well, I think this point about the duration speaks to my earlier observation that our resource adequacy constructs tend to be centered around power, with energy as a secondary issue. And as we move to predominantly renewable and storage resources, we probably do need to rethink that. So I would simply echo everybody's other comments. Regarding new technologies coming down the pike, there's a company in San Diego, Idea Lab, and I believe they're trying to put together a gravitational potential energy storage using heavy weights and cranes. So I think there are technologies that could potentially be essentially energy unlimited, because you just need to keep making big boxes of dirt and placing them on the crane. Maybe there's a limit to how high you can lift them and how many piles of them you can get, but I think that may be a harbinger of quite fundamental technology, new directions of technologies for storage. Another new direction for storage, or maybe not a new direction for storage, but something that I think needs to be borne in mind, is end-use storage. Now, that's relevant, for example, in the chemical industry, where you can stockpile a product. It's relevant in residential contexts where you can, if you have sufficient insulation, you can stockpile heat or cold. And particularly in the context of air conditioning load combined with duct curve, you can imagine residential pre-cooling as a possibility to store energy much more economically, I would put it to you, than storing it in chemical batteries. So I think there are some new technologies. The first one, and new technology, it just means we better think generically about how to represent storage. The second one, end-use storage, again comes back to the inefficient incentives provided by large wedges between wholesale and retail prices. We should think carefully about the implications for end-use storage of exposing those customers to retail prices that differ so significantly from wholesale prices. So again, that comes back to the retail wholesale wedge issue. They're the two things I'd like to observe here.
As well as time variation and retail prices or lack thereof. Would anybody like to follow up on comments by any of the panelists here? Well, I'd like to follow up on Ross's comments. So there are some astonishingly large estimates on the potential for thermal storage just in buildings, pre-cooling and preheating, and of course the utter lack of incentives to do any of that when there's very little time variation in retail rates. That on one hand, we're subsidizing Elon Musk Powerwalls and encouraging people to install that in their homes, spending many times as much as it would cost just to pre-cool and preheat, but there's no incentive to do that. Does anybody else see this as a fundamental flaw in the way that we handle storage in markets, that we are missing what Ross calls incentives for end users to manage their loads to essentially imitate batteries, whether through the thermal storage in their buildings or chemical processes or anything else? Are we going to wind up spending a lot more money on battery storage than we really need to, because of our inability to exploit a very cheap resource?
I think anything in California or Australia almost axiomatically will involve spending a lot more money than we really had to because of poor choices. So I think there's a very obvious answer to that. My concern is not just facetious. It is, as California goes, so does the rest of the world, and the rest of the world simply cannot afford to waste as much money as Californians and Australians can afford, and Germans can afford to waste. So I think it's very critical for California as a demonstrator to the rest of the world to think about cost-effective solutions and not blow a lot of money on very expansive solutions that are simply not translatable to 5 billion other people. So that's my standard soapbox on California and Australia and Germany, for that matter.
Those high costs are affordable if we're talking about 10, 20% penetration of variable renewables, but as we move towards 50, 70 or more, the targets will simply become unaffordable unless we can figure out efficient ways of doing that. Any comments? Nikita, I'd be interested whether any ISOs are concerned about harnessing customer and distributed energy resources that either imitate storage or actually are thermal or chemical storage other than batteries, or is this just not something that's on the radar of ISOs?
I think every ISO is, especially with Order 2222 currently looking into, and they have to, in fact, come up with means to enhance participation from these different technologies. And with time, I think there is going to be a shift in just the way we model these aggregations. So every single ISO today in the U.S. is working on efforts to incorporate them. It does introduce needs for additional changes. Even the discussion around hybrid resources is coupled with having to introduce new models to then better capture the physical and operating characteristics.
So one attendee typed in, vehicle charging and hydrogen as forms of storage are definitely on a lot of ISO's horizons. Is it? I mean, if these are all as cheap to exploit, should this make Elon nervous? That maybe we don't want to be investing in battery manufacturing companies because their market will get wiped out if the really other means of storage are really a lot cheaper if we can figure out how to exploit them. Where should I put my retirement investments? Anybody else want to comment on either distributed storage or anything?
I think the electric vehicle market will keep your retirement invested in Elon afloat, Ben.
Okay. Let's see, there was somebody else typed in and mentioned that vanadium flow batteries, as well as compressed air storage, will solve a lot of issues about degradation and things. It'll be like zero marginal cost of use, no degradation, and it'll be a lot closer to idealized batteries. So maybe we shouldn't worry too much about them. I don't know anything about vanadium flow batteries. Do any of you? Hopefully we'll find out soon. Okay, I think we've exhausted this topic, and so now I can open it up for more general questions about and commentary on market design, the markets being fit for purpose for storage. We have 398 participants, so I'm sure there are a lot of other questions out there. So please insert questions into the chat. If you direct them to me, I might miss them because I'm getting a lot of comments as well. But if you direct them at Gabe or Jimmy, they are filtering them. Here's somebody who says, we already have 60-hour batteries. It's just take 15 normal batteries and bid them right. What's the big deal? Are we missing something there? Or is there some reason why lithium ion is much less suited for that purpose than other technologies?
Well, I think the point there is that the cost is driven by the energy capacity of the battery, not by its power capacity. Things like power electronics are certainly driven by the power capacity, but your ability to reconfigure the batteries bunch in parallel and so forth and add them means that ultimately the driver of cost is how much energy you want to store, and that's fundamentally different to a traditional thermal generator where the cost is how much power do you want to generate. So I think that's just a restatement of the fact that we need to review the drivers of cost as we move to a high renewable and high storage world. We need to change the drivers of cost from one of power capacity to one of energy, the cost of getting energy from the device, or storing of energy capacity to store in the device.
Any other comments? Nikita, did I see you unmute?
We've been floating around with the term of security constrained storage optimization just in the future with what Ross mentioned with focusing on energy, so that's something to look at down the road when there is this very high penetration of storage resources.
Ram team.
Yeah, I would just reiterate. I mean, the comment that I made is, as far as I know, they're not really market constructs that ascribe reliability, resilience benefits of very long duration energy storage. So if I'm not mistaken, in California, you basically say if you have 4 hours of discharge capacity, that's equivalent to having 400 hours of discharge capacity. And I think intuitively we know that's not quite true from a resource adequacy, reliability, resilience perspective.
So is the solution to that to tweak the RA market and the definition of capacity credits, or should we try to fix the spot markets where we don't have enough scarcity pricing or that would appropriately reward longer storage?
Yeah, I mean, I think the glib answer is you could do it either way. the scarcity pricing might be less politically palatable. We kind of saw in Texas what happened with companies like Gritty that were passing wholesale prices on to end customers and so on and so forth. So you always run this risk when you're relying on scarcity pricing that you have to design your market to be robust to poorly intentioned politicians who change things ex post. If you don't have concerns about politicians interfering, then maybe it's less of a concern.
Okay, thanks. Let's see. Here's a comment from somebody online. Essentially all the new batteries that have come into the California ISO system have done so with multi-decade long-term contracts, which provide a negotiated fixed payment. So they're not expecting to earn the margins they need to cover capital costs from the energy market, really. As more batteries are loaded in the grid, 12 gigawatts by 2030 perhaps, declining California ISO market revenues will just shift more revenue needs to the fixed payment component. So tweaking the California ISO market design and software, while potentially helpful for optimally utilizing the storage portfolio, won't alter this trend much. And I'll add to that, I've heard it argued that relying on these fixed payments has really distorted how storage is bid into the markets, and make people almost not really care what if they're operated efficiently. For example, we hear storage owners saying, "Please don't optimize us over multiple intervals. Just accept our bids as we bid them now." And it's argued that those bids are reflecting the terms of contracts providing fixed payments. So this gets into the weeds of things that academics, I know, don't worry about very much. But I know, Nikita, you're very close to the markets. Ross, you've been working with MISO. Luke, perhaps you've heard of this issue, Ramteen. Do we have a problem here by relying on state mandates like in New York and California that get translated into long-term contracts and fixed payments, insulating storage owners from spot market signals, and as a result, distorting bidding and distorting operations? Is that a problem? And I know there are people out in the audience who have raised precisely this issue.
Who are the counterparties to those battery contracts?
So load-serving entities, community choice aggregators, the utilities.
So my general observation would be, if it were a retail restructured world, if they want to sign long-term contracts, I think that's fine. I think the problematic issue is in a deregulated restructured wholesale market, but a regulated retail market. A load-serving entity signing a long-term contract obviously has significant implications for stranded assets. So I think it's prima facie of concern, but I don't know the particulars to know whether it's good, bad, or indifferent.
Okay. Keith, has this been an issue that's been raised in other markets, or is really California much further along?
I think California is much further along. We've heard some similar discussions in hybrids as well about contractual agreements. I agree with Ross. This may be a concern, but I don't have the expertise to answer this more than this.
Okay. I'd like to go on to an entirely different question, which relates to something, Nikita, you were talking about before in terms of the issue of aggregation and distribution systems. So the question is, aggregation retail load flexibility, whether from EVs or home thermal storage, HVAC systems, can provide a storage-like service, but it might be located across multiple buses in the transmission system. And so how do we resolve that problem? And sounds like you had some thoughts on that, Nikita. Anybody else have thoughts on bulk system, distribution system coordination when we have aggregators splayed across multiple buses?
Yeah. In that case, one solution is to want to probably aggregate across bulk nodes that have similar impacts on key transmission lines. So essentially within the same load zone, we have reserve zones today too, where we determine, what the collective impact of one key zone may be on an intra-zonal line. So similarly restrict aggregations across nodes which are not separated by congested lines, so to say. So that could be one approach. And that's what's been observed is being proposed across the different ISOs as well. Some are restricting aggregations across a single transmission node. So there are different approaches being adopted. There are concerns around oscillations of LMPs if you would allow for multi-node aggregations, and how the convergence would happen between the transmission and distribution eventually.
Okay, thank you, Nikita. Any of the other panelists want to comment on this issue of aggregators who are bidding storage but are located at multiple buses?
I think the technically coherent solution is clear. You can only bid a coherent product at a particular transmission bus, and that technical solution, it seems to me, is hard to argue with. And if the aggregators argue that it's too complicated to implement, I would draw their attention to Amazon, Facebook, and all the other folks who can figure out what product I searched for last week and come back to the very same computer and tell me this week what the offer is for it. So it seems to me that the technology to track geographical locations is one that's well trodden in the retail industry. And if these aggregators can't figure it out, maybe they need to go to a different industry. Maybe they need to just sell cars instead of electricity.
Okay, thank you, Ross. Ramtina, Luke.
I was going to suggest exactly what Ross did, which is, from the perspective of modeling the RTO ISO market, I mean, we model resources at transmission buses. So I don't see why we would treat aggregations of resources differently.
Okay, thanks. Luke, you want to weigh in on this? Because I know you've been looking at the issue of storage, location, and ability to exploit transmission constraints to exercise market power. In other words, local market power mitigation. Maybe this is a good opportunity, Luke, for me to ask you if you could talk a little bit about the sometimes surprising and a bit alarming results that you found that battery owners and hybrid facilities, which we haven't been talking about and we certainly could talk about, depending on where they're located in the grid and the amount of capacity they have, could definitely affect local LMPs very significantly. And it's a concern in California where we have, if I understand correctly, a couple of entities own approximately half the battery capacity. It's not as if we got a bunch of 3 megawatt individual owners out there. So, Luke, if you wouldn't mind talking a little bit about what you found in your investigations of, how successful bidding and other strategies could be to manipulate LMPs if you've got a significant amount of storage in the system. I think people would like to hear that. Or maybe we'd like to close our ears.
I think this actually gets a little bit to a point that Ross made in his opening sort of salvo, but we decided to kind of close that Pandora's box quickly, which is the way that transmission is priced in a nodal power system is sort of non-intuitive and perhaps problematic in the way some of the financial instruments represent the actual physical constraints today and all that kind of stuff. And so the sort of question that I had coming out of that is, all right, well, storage is not really like generators in a variety of ways, and hybrid power plants are themselves a different beast in other ways too. And so, is there a way that if they were able to act as a load, modify their offers in a way that creates congestion at a node where there otherwise wasn't congestion, right? Which a generator couldn't do because it just generates; it can't sort of act as a load. Does that then have ripple effects on what the LMPs are at other buses and, the profitability of power plants that the same entity may own that sit at those buses? And at least under certain conditions where you can congest the grid, which, is more common with a large hybrid power plant, where there's less visibility on how the individual components that are DC coupled are actually operating, this turns out to be a thing that you can actually at least from a modeling standpoint, can result.
Thanks very much, Luke. Before I turn to the others and ask them about hybrid plants and market power and other issues, or whether the huge popularity of hybrid facilities has any implications for our market design, what we've been talking about, I'd like to give you a heads up that I'm going to give every panelist the opportunity to make some closing remarks. Take up to 5 minutes if you would like. So if you want to quickly scribble some notes and do that while let's address the issue of hybrid. Okay, so we know that because of the peculiarities of investment tax credit, tax laws, that batteries are able to reap renewable type subsidies by being considered part of hybrid facilities. As a result, they're getting very popular. But maybe there are also technical fundamentals that sharing interconnection costs can allow more efficient use of the grid and so forth. So it's not just an accounting thing. But at any rate, the existence of those facilities, does that change anything that we've been talking about in terms of the challenges to how we manage storage in the spot market and or resource adequacy markets and elsewhere, anything that we've been talking about the last couple of hours? So let anybody who would like to jump in on the issue of hybrids. Nikita?
So the same discussion that we had with state of charge management and standalone storage does translate to concerns around hybrid resources as well. What's being suggested is maybe have multiple options wherein you let the hybrid resource participate as a single resource without the ISO having any visibility into the individual components that make up the hybrid resource. So no visibility into the state of charge or the renewable forecast, so to say. The other way would be to then model them as two independent resources and maybe limit their injection into the grid or withdrawal through some sort of a constraint, an interconnection constraint, where you could vary how much they charge from the grid based on IPC considerations. The concerns around state of charge management may be greater in the single resource option when they're participating without any visibility. So we may want to consider still telemetering these resources to still ensure that state of charge is available to provide essential reliability services. But simulation studies still need to be done to show that there are concerns that may arise and what are the benefits of these different modeling options.
Thank you, Nikita. Ross, do you have anything to add about hybrid facilities? And
I think Nikita's summary was just very concise. I don't think I have anything that would be helpful to add. I think that was a really nice comparison of the two options. So nothing to add.
I suspect, given your advocacy of realistic physical models of that, as how storage actually operates, and preference for not allowing them to bid an offer except for their ending state of charge, you might prefer more visibility into what's under the hood or what's under the bed covers for depending your choice of metaphor going on with the hybrid facilities. Is that right?
Absolutely correct. Absolutely correct.
Okay. Ramteen, do you have any thoughts about whether hybrid facilities present any particular technical or economic challenges that we need to recognize?
The only thing I'll add is some of the incentive mechanisms that you mentioned, some of the tax credits can be somewhat distortionary. You end up with very different designs in terms of how the systems are configured, and then very different operational profiles as well. I mean, in some extreme cases, basically you have a battery that is effectively just being used to run your renewable energy through the battery. You lose whatever percent of the energy through the energy storage cycle. So you're wasting energy right there. You're basically degrading the battery, and you're not using it for anything kind of, you're very limited in using it for things that are socially beneficial. And that's just because that's kind of how the tax policy treats it.
Right. You're terrified of losing your investment tax credit.
Exactly.
But fortunately, this will pass. These things are getting will get transitioned out. But Luke, you spent a lot of time in your dissertation on hybrid facilities. Anything, whether technically, economically, or otherwise, that the ISO should be thinking about with hybrid facilities that. If we just think about pure vanilla storage, we would be missing.
I think the only thing I saw is that if the hybridization of the facility allows you to somehow hide the technical characteristics of the generator that's hybridized with the storage, right? That you might imagine that, if we can make sure that the individually sited wind plant is sort of not physically withholding any of the generation that's available, but if somehow the hybridization with the storage because of the changes to the parameters of the offer, if only a single offer is submitted to the market, could allow, under certain circumstances, for hiding of some of the technical characteristics of the wind facility or the generator that's hybridized. And that can then create some concerns, again, because of sort of the point Ben's made multiple times that if you no longer are representing the physical characteristics of the generator, that way lies market power or other types of concerns.
Okay. So speaking of distortionary aspects, somebody from the audience sent me a note saying, in the West, solar wind resources may be located far from load centers, and having hybrid batteries, the resource location may be very wasteful because batteries might be more useful close to load, and the tax advantages may put a thumb on the scale. Those of you who do resource planning, and so forth, do you see this as an issue that we should be putting more storage in the load centers rather than way out at the end of the interconnectors, and we're wasting a lot of money as a result, or is this not an issue?
Seems like it depends on whether the transmission system can deliver the stuff that's out at the ends of the lines to the load or not, right? I know something I've seen in some resource adequacy modeling I've done is that if you have storage closer to where load pockets are, it can better utilize the existing transmission system to, say, charge earlier in the day to deliver power later in the day when the system is more congested. And in principle, that leads to a higher capacity credit for that storage that's in the load center as compared to, storage that can't use the existing transmission system to deliver power to load.
Anybody else want to comment on the issue of location of storage and incentives for that?
Well, it's clearly an empirical issue, right? We would have to analyze how big an effect is the subsidies in putting the thumb on things.
And then there's also the aspect of why hybridization. I mean, transmission, like Luke mentioned, is a key benefit of maybe putting storage close to the load. But the reason why some of these resources are hybridizing is maybe the time in the interconnection queue is smaller. If you were to just get into the queue with an existing request for maybe a renewable resource, so just by the time the request is approved, so that's one reason. Then there may be also some benefits from using the same inverter and not investing in components. So LBNL has done some work around this as well to just analyze why hybridization, what are the benefits of maybe having these resources located independently versus coupling them. These are the key reasons which have been pointed out to why these resources are hybridizing. Otherwise, from a transmission perspective, I mean, it's just load balance, so it shouldn't matter if it's located near the load. It's better, actually, yeah.
Okay, thanks, Nikita. Any last comments before we go to the final round where you all can make your closing remarks? But before you do so, and I will, let's see, I'll call on just randomly Nikita, if you don't mind, if I can call you first. But before I do so, I want to thank the organizers, Elliot for kicking this off, Gabe and Jimmy and the ISO staff who are working on storage and the Storage Enhancements Initiative and who thought of having this forum, which I really have appreciated, to the 400 plus attendees for coming and for your active participation in the discussion and questions, and finally to the panelists, Nikita, Ross, Ramteen, and Luke, for the preparation you made for this and your active and fun engagement throughout. So if we could start with Nikita, then I'm going left to right across my screen. Nikita, Ross, Luke, and then Ramteen will have the last word.
Thanks, Ben. Maybe I'll sum up my comments that I'd mentioned earlier. I think there are regional differences that occur, I mean, that exist across the different systems, and there are priorities that each system has. So it's important to consider these differences when you're introducing new designs and participation options. Granular models tend to provide theoretical efficiency gains, but they also add complexity to the market clearing software. So that may not be desired by all the participants. So the industry should in general strive to allow for greater flexibility in participation options when it's possible, but noting that different perspectives of market participants who prefer different models or modeling accuracy details may still exist. It's important for us to periodically assess these participation models and allow for newer technologies to enter the market to enhance competition, but we have to subject all the changes to reliability, especially because they can have changing impacts with larger penetrations of these resources. So it's always a trade-off, and it's important to see if there's a fundamental issue with the market design before introducing new products, and how we can enhance the market design. Is there an existing product that can hack at the issue or not? That's how I'd like to sum it up. But thanks for the opportunity. This is a great discussion.
Well, thank you, Nikita. And of course, the service that EPRI provides by convening all the ISOs and talking about short to medium to longer term market design issues, that's precisely the sort of forum like this one, which we are organizing on an ad hoc basis, but you systematically do, that helps folks fix folks' attention on the most important pressing issues and on longer-term solutions rather than short-term kludges with the baling wire and duct tape. Let's see. I think the next one on my screen is Ross.
Well, I would simply close. Thank you, Ben, and to everyone on the panel. I would simply close by repeating the philosophical approach of designing the office structure to match the generic technology. And with storage coming along, I, again, would maintain that we need to think about the features that are necessary to match the storage technology. Maybe we haven't got them all figured out. Similarly, when when markets were being set up, we haven't figured out all of the salient characteristics. One of them that came up today were these dynamic limits. Maybe they're significant, maybe they're not. As you characterized it, Ben, very nicely, the first order issue is state of charge. Let's get that into the model. And then if that's insufficient to represent the salient, all of the most important characteristics, let's add some additional bells and whistles, while also always bearing in mind the trade-off between computational issues, tractability, and intelligibility. But overall, I would still advocate that we match the offer to what we believe are the salient characteristics of the storage technology as a guiding principle for how to change our market designs.
Thank you, Ross. As the old-time preacher said, tell them what you're going to tell them it, and tell them what you told them. And we have got your message on that loud and clear. Whether folks agree with it or not is another matter, but really appreciate you bringing that perspective here. Okay, I think the next one on my screen is Luke.
All right, so first I'd like to just echo what other folks have said. Thanks so much to Ben and to all the attendees for listening in and for organizing this and for a number of really difficult questions that I'll be thinking about in the days and weeks and maybe years to come. So I think with that said, it seems like to me the major takeaway here is just sort of the Einstein aphorism, I think it's attributed to Einstein, that we should make things as simple as possible, but no simpler. And, Ross and Nikita have helpfully defined what that means in some regards in terms of representing the physical characteristics of generators, making sure we always consider trade-offs between the computational complexity and the sort of added value of the additional parameters in the model. And so the only thing that I'd like to say to sort of add on to that is, Ben and Ross have been doing this for a long time, longer than I have, but at the same time, it seems to me like what we've learned in the past is that, being nimble and being able to adjust, we're not going to get everything right the first time around, and we'll learn more as new technologies come into the market and as participation models, business models evolve, tax credits change, all that kind of stuff. And so I look forward to revisiting these issues in the years to come and sort of trying to remain nimble in learning from the actual experience of CAISO and other places in operating these resources in competitive markets.
Okay, thank you, Luke. So now we go around the virtual table to Ramp team.
All right. Well,
closing remarks, anything that you really want us to remember today.
All right. Well, first of all, thank you, Ben, CAISO staff, and attendees for the opportunity to speak today. Really just, I'll add two things to what's been said already. One is that, it's heartening to see that this is happening now. I said at the outset, I think with the technology mix today, the market designs are reasonable and adequate, but, looking into the future, there are things that need to be addressed. And I think it's better to be proactive as opposed to reactive. The other is, I think making sure that market designs that really capture the value of long duration energy storage, that is kind of key and critical. A lot of studies show that long duration energy storage is going to be a big player in these deep decarbonization scenarios that we need California and other energy systems to move towards. And so, if we don't anticipate having, let's say, federal policy or something that's going to move us in that direction, then, probably an even better way to get there is by having good, strong market designs that, provide incentives and incentivize those types of resources being built, incentivize in the sense that, captures the value that they provide. to consumers and societal value that they provide. So those are really just the two things I want to add beyond just echoing what the other panelists said.
Okay. So all your closing comments are terrific, just like the earlier discussion. And so at this point, I'd like to hand it over to Gabe for the closing blessing.
And I think we've got Khaled Abdul Rahman, our Vice President of Technology, online, and he'll be doing the closing today.
Okay,
yes,
terrific.
Yeah, thank you, everybody. Good afternoon, everyone. And I will make my remarks actually very short because of the limited time that we have. I would like to thank Dr. Ben Hobbs and all the respected panelists for, wow, an incredible wealth of information and consideration ranging from special characteristics of the energy storage resources to market design to procurement, as well as bidding and financial compensation. I mean, there's so much was covered during this few hours that we've talked. I tried to make notes as I was listening to all the panelists, and I will go through some of my item, not all of them, but at least some of the ones that I found really very interesting, and maybe some of them to summarize. It is obvious that we just cannot fit these new resources within the traditional resource models and market rules for the sake of faster participation or incorporation of those resources into the market. We have to really design and come up with the models and the rules that will fit with the characteristics of those resources. We cannot just use the traditional supply templates and load templates. These are not generator supply and load resources. Having an efficient market dispatch and reflective market prices of the grid and the market conditions is crucial, and we should continue to investigate mechanisms that are consistent with this principle. Like any other limited energy resource, most of the energy storage resources in our markets are energy limited, and this means that there may be lost opportunity cost when limited resources are optimized in a market that does not capture the whole time span of the limitation constraint and or doesn't settle all the intervals in the market horizon. This is what's happening in the real-time market. That doesn't happen in the day ahead because we settle all the intervals in the day ahead. This is why we are interested in a continuous discussion on this issue as well. Energy as a measure rather than capacity. It stood actually, I mean, I put it in parentheses here, and I would like to use it continuously because this is really rhyme with what the same way I'm thinking about this issue. There need to be, we have to, I mean, this also, the sentence that says also that we need to use fewer bidding parameters that are more static, so they don't change. Similar to how we have it for the traditional supply resources, where we use capacity, price, bids and offers. Does this actually fit the new storage limited energy resources, or should we probably use more of the state of charge price type of bidding that may make some of the modeling of some of the issues that has been discussed over the phone maybe easier, especially especially the way that how the storage is charging and discharging and how fast it can charge and discharge. Of course, this will make the technical formulation more difficult, and we have to have some more innovative approaches for that. Longer horizon versus shorter horizon issue. I think I would like just to point one other major issues to think about, which is the accuracy of the forecast for those future hours. In the real time, we only have a forecast for maybe a few hours in advance in a good accuracy. If we try to run for a longer period, or even get information from an intraday function like a unit commitment, for example, the question of accuracy there, and the question of the financially binding bids for those hours. We don't have financially binding bids for future hours. We only have it like for a couple. So this is now the question there is that can we use the information that if we have a function that can run, can we use that information to bind the dispatch of the storage resources? There is also the opportunity cost. I mean, I forget to mention that we do have, for the limited energy resources, we do have opportunity cost calculator function that helps us to determine a reasonable value for an opportunity cost that can be added to the default bid when we come up with a reasonable default bid. Can that process be maybe modified to include some of the calculation for that, especially the longer term? Finally, I feel like today's forum provided us with a lot of things to think about and triggered some interesting ideas as well, and solutions that need to be, that needs to be maybe discussed even further. I mean, I like the principle that Nikita said, it has to be implementable and also operationally feasible for it to be successful. On behalf of the ISO, I look forward for this continuous collaboration among all the interested parties to successfully leverage these new resources on our steady path to the decarbonization. Thank you. And I will give it now back to Jamie for the wrap up.
Thanks, Khaled. Can everybody hear me?
Yeah. Yes.
Well, I appreciate that closing remarks. Very nice of you, and thanks for your time, and Elliot as well, and to all the panelists, and Ben, once more, really appreciate your input and time in preparation to make this a really great show for folks. And of course, all those stakeholders out there, thank you for your questions. We really appreciate the back and forth. We thought it went very well. We hope you think the same. This was posted onto the initiative page on the public forums webpage. So look for the recording to be available in the next couple of business days. And with that, have a very great rest of your day, folks.